Suppose the ladder is 10 feet long and the top of the ladder is sliding down the wall at a rate of 0.8 feet per second. Compute the average rate of change in the position of the bottom of the ladder over the intervals of time from 0 to 0.5 seconds, 3 to 3.5 seconds, 7 to 7.5, 9.5 to 10, 12 to 2.5 seconds. And how do we interpret these numbers? So, we are going to start by calculating the output in feet. The first one uses 0 in the time. So we're going to use the square root of 100 minus 10 minus 0.8 times 0 squared. That means 0.8 times 0 is 0. So we have 100 minus 10 minus 0 squared. 10 minus 0 is just 10. So we're going to take 10 and square it. 10 squared is 100, and 100 minus 100 is 0. If you square root 0, you get 0. Now we're going to use 0.5. So I'm going to replace the 0 in the parentheses with a 0.5. 0.8 times 0.5 is the first step. So we're going to multiply 0.8 times 0.5 to get 0.4. Ten minus 0.4 is 9.6. And 9.6 squared is 92.16. When you subtract that from 100, you get 7.84. And the square root of 7.84 is 2.8. Then we're going to change 0.5 out for a 3. .8 times 3. That is 2.4. 10 minus 2.4 is 7.6. 7.6 squared is 57.76. And when you take that away from 100, you get 42.24. And then we're going to square root that and round it up to 6.5. Now we're replacing the 3 with 3.5. 0.8 times 3.5 is 2.8. 2.8 taken away from 10, so 10 minus 2.8 is 7.2. 7.2 squared is 51.84. 100 minus 51.84 is 48.16. And 41.86 with the square root gives us 6.9. You're going to continue this process all the way down the table. Then when it comes to the part about the rate of change, what we're going to do for those is we're going to calculate how much it has changed in that time interval. So I'm going to do the first couple for you, and then you'll do the last ones on your own. So the interval from 0 to 0.5, 0 to 0.5. That is a change in time of 0.5 and a change over here of 2.8. So from 0 to 0.5, we have 2.8 as our change in feet and 0.5 as our change in time, which is a rate of 5.6 feet per second. Then for the next one, so I've done 0 to 0.5. For the next one, from 3 to 3.5. That is also a change of 0.5 seconds, but it is a change of only 0.4. From 6.5 to 6.9 is 0.4. And so that is a change of 0.8 feet per second. And then you're going to continue for 7 to 7.5 and 9 to 9, or 9.5 to 10 and 12 to 12.5. So you're going to need to finish those last three and fill in the rest of the table. Then in number 2, it says, will the length of the ladder L and any constant speed of sliding on of the top of the ladder V, feet per second, ever produce a constant rate of change in the position of the bottom ladder? Is this the same rate? No. 5.6 feet per second is much faster than 0.8. So will they ever produce a constant rate? And the answer to that is no. Eventually, the ladder is going to hit the ground, and being on the ground would have a rate of 0 feet per second. It's not going to continue to fall below ground level. So, in order to have a constant rate, the rate would have to be 0, but then it wouldn't be sliding. So, we can say, no, it's not going to produce a constant rate. Eventually, the rate will reach 0 because it will be on the ground.